Hi students, now we are going to derive the relationship between the radius of curvature and the focal length of a concave mirror. So this question is usually asked for 3 marks. Derive an expression between R and F. We already have studied in the 10th standard. R is equal to twice the focal length. Is it not? We are going to derive this relation only. So first, for that a relevant and a neat diagram we have to draw. You see that AB is a portion of a spherical mirror and it is a concave mirror. You draw this concave mirror having large radius of curvature so that it is almost flat. Don't draw a steeply curved mirror so that the disproportionate figure will not be correct. So draw a figure such that this portion AB is curved but almost flat. Okay. Now draw a straight line, namely principal axis, which passes through the center of curvature C, then the principal focus F and the pole of the mirror P. Okay. Then you take one incident ray. Okay. So I have taken a ray which is parallel to the principal axis. So the incident ray is now parallel to the principal axis. It is incident at a point M on the mirror. Now if you join the points center of curvature C with the point of incidence by dotted line, this dotted line, if it is extended, that will be normal to the reflecting surface. CM, when it is extended, it will be normal to the reflecting surface, and hence the angle made by the incident ray with the normal, this angle is angle of incidence. The angle made by the incident ray with the normal is the angle of incidence I. Okay, we have studied the rules for the formation of the images. At that time we have studied that when a ray of light is incident parallel to the principal axis, the reflected ray must travel through which point? Through the principal focus. Is it not that? So the reflected ray from M travels through the point F in this direction, so that this angle is called the angle of reflection. By the laws of reflection, angle of reflection and angle of incidence must be same, so I can take this angle is also angle of incidence only. Is it not? By the law of reflection. Okay. Now you see here, this angle I is alternated here. The alternate angle MCP. MCP is the alternate angle of this I. So this angle also must be equal to the angle of incidence. Then you take this angle which is made at M, this I plus I, 2I. This 2I is alternated here. Therefore, this angle MFP must be equal to I plus I, that is equal to 2I. So here 50% of the derivation is in understanding these two angles made on the principal axis. So now I am going to write this angle MCP. Okay, this angle MCP is equal to I and MFP is equal to 2I. So this angle MFP is equal to 2I. So this is the first point to be understood. Next one is the purpose of drawing this mirror AB almost flat with a large radius of curvature is, so we can assume that this portion MP is almost straight. This portion MP is almost straight so that it is perpendicular to the principal axis. Understand? That is the purpose. Now I am going to consider two triangles, namely MCP, which is right angled at P, and also MFP, which is right angled at P. These two right angled triangles. Now first I will take the triangle, right angled triangle MCP. MCP. In this right angled triangle, what is the tangent value of this angle of incidence? I. So tan of I must be equal to opposite side by adjacent side. Okay. So which is the side opposite to this angle I? It is a PM. Okay. This is equal to PM divided by, this is PC. Adjacent side is PC. Okay students, now you tell me why I have not written MP divided by CP. It is after all side only, is it not? But always keep it in mind, you write all distances starting from the pole of the mirror by the sign convention. So, the distance from pole to the center of curvature, PC, that is called radius of curvature. The distance from P to F is called the focal length, is it not? Like that, P to M is the height of the object. Like that, always you have a practice of writing the distances starting from the pole always. It is a good practice. Okay. So, this is a tan of I. Next, I will take another triangle, the right angled triangle MFP. You see here, MFP is right angled at P. So, what is the tangent value of 2I? So, tan of 2I is the ratio of the side opposite to the angle 2I divided by adjacent side. So, which side is opposite to this angle 2I is PM. So, once again it is PM divided by PF. So, this is a PF. Okay, these two angles I and 2I are very small because these rays which are traveling parallel to the principal axis are very close to the axis also. Such rays are called as paraxial rays. Okay, for paraxial, paraxial rays which are traveling closer to the principal axis. The angle I and 2I are very small angles. Therefore, tangent of the angle of incidence is nearly equal to I, and tangent of the angle 2I is nearly equal to 2I. Okay, nearly equal to 2I. So, instead of tan I can write now I itself. Understand? Therefore, this tan I is written as I. So, I is equal to PM divided by PC. So, this is our required equation number 1. Similarly, tan 2I, instead of tan 2I, I can write what 2I itself. That is equal to PM divided by PF. So, this is equal to PM divided by PF. And this is equation number 2. Okay. Now, you look at the equation 2, left hand side is 2 into I. Instead of this angle I am going to substitute PM by PC from equation 1. Understand? So, instead of this 2 into I, instead of I can substitute PM by PC. So, 2 into PM divided by PC is equal to PM divided by PF. Now the common factors PM on both sides gets cancelled. Okay. So this is cancelled. So 2 divided by PC is equal to 1 by PF. Okay. I can call this as equation 3. So that we can remember the sequence of steps. Now you tell me what is the distance from the pole to the center of curvature. Yes, radius of curvature is correct. So the distance P to C is equal to R. Okay. So this is called the radius of curvature of the concave mirror. And P to F, the distance pole to the principal focus. This is denoted by the symbol F, and this is called focal length. So instead of PC, I can substitute what? Capital R. Instead of PF, I can substitute the small f. Okay, therefore 2 divided by R is equal to 1 by F. Cross multiplying, what do you get? R into 1 is R, 2 into F is twice the focal length. So this is equation number 4 and the final equation. Therefore, radius of curvature is twice the focal length. Very simple derivation only. First you draw the diagram properly and you easily derive the equation. I hope you must have understood well. Fine.